All right, we're back with the second part of this video series. So inequalities containing or. Another type of compound inequality contains the word or. A compound inequality containing or is true if at least one of the inequalities is true. Its graph is the union of the two inequalities because there might not be an overlapping part, but if it's or, it can be either this one or that one. So at least one of those inequalities has to be true so you can graph both of them. So if I have x is greater than or equal to 2, or excuse me, greater than 2, x is less than or equal to -1, notice there's no overlap. But if it's an or inequality, at least one of those have to be true, so I can shade both of those parts. Okay? When solving problems involving inequalities, within is meant to be inclusive, so use greater than or equal to or less than or equal to. Between is meant to be exclusive, so use strictly less than or strictly greater than. Okay, the human ear can only detect sounds between the frequency of 20 hertz and 20,000 hertz. Write and graph a compound inequality that describes the frequency of sounds humans cannot hear. Okay, the problem states humans can hear frequencies between 20 hertz and 20,000 hertz, and we are asked to find frequencies humans cannot hear. So the frequency is at most 20 hertz, or the frequency is at least 20,000 hertz. So f has to be less than or equal to 20, or f is greater than or equal to 20,000. So remember, between means strictly less than or strictly greater than. So people can hear between 20,000 and 20. Okay, that's where they can hear. But where they cannot hear, the moment you stop hearing is at 20 and at 20,000. So that's why the intervals where you do not hear include the 20 and the 20,000. So if we graph those, I graph everything less than 20 or greater than 20,000. Again, we had to go tick marks meaning 2,000. So if I graph 20, that'd be really close to 0. So just be careful that dot is not technically on 0, it's on 20. Okay, and I'm graphing the intersection, which means take both at the same time. So it's either one. Notice they don't overlap. So that's it. Notice that the frequencies do not intersect because humans cannot hear sounds at frequencies less than 20 hertz or greater than 20,000 hertz, so that the compound inequality is f, such that f is less than or equal to 20 or greater than 20,000, greater than or equal to. Those should have the or equal to symbols on there. Okay? All right, so a company is manufacturing an action figure that must be at least 11.2 centimeters and at most 11.4 centimeters tall. Write and graph a compound inequality that describes how tall the action figure can be. Go ahead and pause the video. All right, we're back. Now, did you notice that they kind of threw a curveball in here for you? Because it's and. So it has to be at least 11.2. So the height has to be greater than or equal to 11.2, and the height has to be less than or equal to 11.4. So if I graph those, here's 11.2. So closed circle, shade to the right. Here's 11.4. Closed circle, shade to the left. Oops. The overlap would be closed circle on 11.4, closed circle on 11.2, shade in between, and it would be the set of H such that H is between 11.4 and 11.2, including 11.4 and 11.2. Okay, so just be careful there. All right, we're going to solve and graph a union. So this one's pretty cool. Solve a negative 2m plus 7 is less than or equal to 13, or 5m plus 12 is greater than 37, then graph the solution set. So I'm going to take each one separately and solve those down. So this one I subtract 7 from both sides. This one I subtract 12 from both sides. Then I get negative 2m is less than or equal to 6. 5m is greater than 25. This one divide both sides by negative 2. This one divide both sides by 5. Notice this one, since I divided both sides by a negative, I reversed the inequality symbol. So here you have m is greater than or equal to negative 3, and this one m is greater than 5. All right. So I'll graph m is greater than or equal to negative 3, and I graph m is greater than 5. But be careful here, okay? Since it's an or, you treat it differently than you would treat an and. If this was and, we would have just graphed from 5 with an open circle on up because that's where they overlap. But remember, or means that either one of the inequalities, so at least one of them should have to work, so you graph both of them, okay? So we graph everything from including negative 3 on up. All right, sometimes that confuses people, but if you think about what or means it has to be at least one of the inequalities, so you graph them both. And means it has to be both inequalities at the same time, so you graph the overlap. All right? Notice that the graph of m greater than or equal to negative 3 contains every point in the graph of m greater than 5, so the union of the graph, so the union is the graph of m greater than or equal to negative 3, and that's the solution set. All right, let's solve these. Go ahead and pause the video. All right, we're back. So for the first one, I'm going to subtract 1 from both sides. And I get a is less than 3. And then this one, I'm going to add 1 to both sides, and a is greater than or equal to 4. So if I have 3 here, less than 3 is open circle on 3, everything to the left. This one, open circle on 4, but shaded in, I mean, because it's where equal to, and everything greater than it. Since it specifically said or, I can take either one. So close circle on 4, everything to the right. Open circle on 3, everything to the left. And it's the set of a such that a is less than 3 or a is greater than or equal to 4. Okay? Let's do the second one. So you have a is less than or equal to 9. Nothing to do with that one. The other one, you have to subtract 2. So you have 4x is less than 8. Divide both sides by 2. X is less than 4. So the first one, I have 9. Close circle, shade everything less than. Second one is 4, open circle. It's less than 4, everything to the left. But since it's or, I take them both together. So I shade from 9 on down, everything less than 9. And the solution would be x such that x is less than or equal to 9. Again, it's not an and statement, so you don't just do the overlap. This is an or statement, so you take both together and you combine them. And the solution set to x less than 4 is contained in the solution set for x less than or equal to 9. So the solution set is just x less than or equal to 9. All right, guys, that's it for this section. Please continue on to your assignment. And as always, reach out to me if you have any questions. Take care.